Okay, before we look at how to divide complex numbers, we're going to look at a familiar problem which is closely related to dividing complex numbers. If we had a fraction where we've got 3 divided by 5 plus root 2, often we don't like the fact that we've got a surd in the denominator, and we try and write it in this form, a plus b root 2. And you should know that in order to solve that, what we do is we multiply the top and the bottom of this fraction by 5 minus root 2. And the reason why we do that is because when we multiply the denominator by 5 minus root 2, we get a number without a surd in it. In this case, if we multiply the denominator, simplify the denominator, we'd get 25 minus 5 root 2 plus 5 root 2 and minus 2. And the reason why we've done that is because these surd terms with a surd in it cancel each other out. And on the numerator we'd have 15 minus 3 root 2. So the way that helps us is because now we've got 23 on the denominator, so we can split that up into two fractions. We can write that as 15 over 23 minus 3 over 23 root 2, which is of the required form. So we're going to do a similar thing with complex numbers. So here we've got two complex numbers and we want to divide them. And we don't like the fact that we've got a complex number in the denominator. So what we're going to do is we're going to remember the fact that if we have a complex number z and we multiply it by its complex conjugate, z star, we know that this is always purely real. We get rid of the complex part. So we're going to apply that fact, and we're going to times the top and the bottom of this fraction by the complex conjugate of the denominator. If we do that, that's going to ensure that the denominator, when we multiply out the bracket, is going to be purely real. Because here we've got the complex number times by its complex conjugate. Well, if we times the bottom by 2 plus 3i, we need to times the top by 2 plus 3i. And this method is always going to be the method we use to simplify dividing two complex numbers. So it's really easy to make algebraic mistakes when you do that. So I would recommend taking a few steps to make sure that you don't make any mistakes. So let's start off by expanding the brackets. We're going to have 10 plus 15i plus 8i and plus 4 times 3 is 12. I times I is I squared. And on the denominator, we're going to have 4. 2 times 3i is plus 6i. Minus 3i times 2 is minus 6i. And minus 3i plus 3i. Minus 3 times 3 is minus 9. I times I is I squared. And as we would expect, we get these two terms that cancel each other out. And that's going to ensure that we have a purely real number with the imaginary part 0 on the denominator. So let's simplify the numerator. We're going to have 10. Collect together these terms. 15i plus 8i is 23i. And I squared is minus 1, so we've got minus 12. 12 times minus 1 is minus 12. And on the denominator, we've got 4. These two green terms cancel each other out. Minus 9 times minus 1 is plus 9. So we're going to have 10 minus 12, collect together the real terms, is minus 2 plus 23i. And on the denominator, we're going to have 4 plus 9, which is 13. So we want to write that really clearly in this a plus bi form. So we're going to split this up into two fractions. Minus 2 over 13 plus 23 over 13i. Now, before you have a go at the exercise, you can have a go at a few more questions, or you can just have a go at the exercise now, you choose. So if you want to have a go at a question before you have a go at the exercise, So you can work out what this is in the form a plus bi. I'll give you a chance to pause the video. So you should have multiplied the numerator and denominator by 6 plus 8i, because the conjugate of the denominator was 6 plus 8i. And then if you expand the brackets, you would end up with this. Replace I squared with minus 1. And then at this point, once you've simplified the numerator, split it up into two fractions, minus 22 over 100 and plus 54 over 100i. There's a slightly more complicated one for you to have a go at before you have a go at the exercise. Again, I'll give you a chance to pause the video. So in this case, because we've already got a complicated numerator, what I would recommend doing is I would expand the numerator first. So I've done 3 minus 4i times by 3 minus 4i to get that on the top. And then I've simplified that to minus 7 minus 24i. And then I've multiplied the top and the bottom by the complex conjugate of the denominator, which is 1 minus I. And then if you do that, you should end up with that as your answer.